Hi everyone, this video goes over the first section in book 1, which is applied volume. The reference sheet that you're going to need is this one. This is the one that you have for the Regents exam. All right, so we're just going to go through the questions in the applied volume section. So the first question says, Izzy is making a homemade clay pendant in the shape of a solid hemisphere, that's half a sphere, as modeled below. Each pendant has a radius of 2.8 centimeters. How much clay to the nearest cubic centimeter does Izzy need to make 100 pendants? So sphere, 4/3 pi r cubed. But we're going to have a hemisphere, so we're going to divide this by 2 when we get our answer. So we've got 4/3 pi. Our radius here is 2.8, so 2.8 cubed. Throw this in our calculator. And we have this. 91 point something, and then we're going to divide it by 2. So we have 45.97616,129. How much clay to the nearest cubic centimeter does Izzy need to make 100 pendants? So we're going to take this number and we're going to multiply it by 100. And we're going to round to the nearest cubic centimeter so you don't get a point off. This is only worth 2 points. So 4, 5, 9, and then either this is staying a 7 or going up to an 8, and in this case, it's going up to an 8. Also, since it says cubic centimeter, you know that this is a volume question. All right, let's look at the second one. It says a concrete footing is a cylinder that is placed in the ground to support a building structure. The cylinder is 4 feet tall, and 12 inches in diameter. These are not the same units. A contractor is installing 10 footings. If a bag of concrete mix makes 2/3 of a cubic foot of concrete, determine and state the minimum number of bags of concrete mix needed to make all 10 footings. So they're making 10 of these, and we want to figure out how many bags of concrete you need. Now, since this is in cubic feet, we want these to be in feet as well. This is already in feet, 4 feet. This is 12 inches. Let's call it 1 foot. Okay? Which means that the radius is going to be half a foot. 0.5 is what I'm writing right here. So if I go back here, I'm looking at the cylinder. Cylinder. Volume equals capital BH, where B is the area of the base. So capital BH, the area of the base is a circle. So the area of that is pi r squared. So we've got pi r squared times h. Pi, the radius is 0.5 since we're talking feet, half a foot times 4 feet. .5 squared times 4. So I just have 1, so which is just pi. So this is pi, 3.14, and that gives us 1 footing. Since there are 10 footings, we're going to multiply this by 10, which will give us 10 pi. So this is the volume. Now, it says a bag of concrete mix makes 2/3 of a cubic foot of concrete. We have 10 pi cubic feet. If you would rather work in decimals, this is really what you have. So you have about 31.41 cubic feet. 1 bag makes 2/3 of a cubic foot. So determine and state the minimum number of bags of concrete needed for this. So I'm going to take my 31 or my 10 pi, and on my calculator I'm going to divide it by 2/3, and that'll tell me how many bags. So this is cubic feet, and this is 2/3 of cubic feet as well. So I get about 47.123 bags. So I need 47 and change bags. So this doesn't actually say to round, but I can't buy 47.1 bags. So I'm gonna have to round this up to 48 bags. All right, how about the next one? It says the diagram below models a countertop designed for a kitchen. The countertop is made of solid oak and is 3 inches thick. So notice we've got 3 inches for the height, and then we're in feet here. If oak weighs approximately 44 pounds per cubic foot, so here's feet, so we want everything to be in feet. The approximate weight in pounds of the countertop is, all right, so we want everything to be in feet. We've got 10 feet, 3 feet, 3 inches. So 3 inches out of 12 inches, and maybe you don't need to do this on your calculator, but that's 0.25. So we're gonna use 0.25 for anywhere we see 3 inches, 0.25 of a foot. All right, so you can do this a couple different ways, but I'm just gonna split it. I'm gonna do 2 sections. Section 1 over here and section 2 over here. So I'm gonna do section 1 first. This is a rectangular prism. So the area or the volume for a rectangular prism is capital BH. Capital B is the area of the base. In this case, the base is the length times width. So in this case, I've got 12 feet and 3 feet for my length and my width, and my height is my 0.25. So I've got 9 for the first volume. For the second volume, I'm gonna do the same thing. Put that over here. Capital B times H, which is still length times width times height. The length in this case is 3. Now, this is where we have to be careful. This whole thing is 10, and this little piece where I cut it, that's 3, because this over here is 3. So just from here to here is gonna be 7. So I've got 7 and 3, and then 0.25 again. So 5.25. So my total volume is gonna be 9 plus 5.25, which is 14.25. So this is the total volume in feet cubed. Now, every foot cubed weighs 44 pounds. So I'm gonna have to multiply this by 44 to figure out the total weight. So 14.25 times 44, 627. 627 pounds. 627, this says approximate weight, so that's really close to 630. It's option 1. All right, next page says, first one's about baseball. A packing box for baseballs is in the shape of a rectangular prism with dimensions of 2 feet by 1 foot by 18 inches. Each baseball has a diameter of 2.94 inches. Just determine and state the maximum number of baseballs that can be packed in the box if they are stacked in layers and each layer contains an equal number of baseballs. All right, well, okay, let's start off with, we're talking about the volume of a rectangular prism, and we have a box that's given to us that's 2 feet by 1 foot by 18 inches. And the baseball has a diameter of 2.94 inches. Now, 2 feet is 24 inches, right? And 1 foot is 12 inches. So let's just do this in terms of inches. So you're going to be stacking baseballs like this way. And you're going to be stacking baseballs this way as well. And we're trying to figure out how many baseballs we could fit. Every baseball is 2.94 inches long. So if I take 24 and divide it by 2.94, I'm going to get 8. But I got to round down because I can't have point. But I could do 8 baseballs across. That's 2 feet. And if I go this way, 1 foot, I've got like 4.08, which is like 4 baseballs. Height-wise, or not height-wise, I've got 8 this way, I can fit 4 this way. And then how about for the height? 18. So 6 point something? So I can fit 8 baseballs across, 4 baseballs wide, and 6 baseballs high. So if I do my volume of a prism in terms of baseballs, capital B times H, length times width times height. So 8 times 4 times 6, which is 192 baseballs. The weight of a baseball is approximately 0.025 pounds per cubic inch. Determine and state to the nearest pound the total weight of all the baseballs in the fully packed box. So a baseball is a sphere. If I steal the sphere formula, I've got 4/3 pi r cubed. My diameter is 2.94, which means my radius is 1.47. So 4/3 pi times 1.47 cubed is 13.305788843. This is the inches cubed, the volume in inches cubed, and we know that it weighs 0.025 pounds. So 0.3326447107. This is for one baseball. So one baseball weighs this much, and we have 192. So I'm gonna multiply this by 192, and I get like 63.86, which to the nearest pound is 64 pounds. Also, you can multiply these in the opposite order. You could take this, multiply by 192 first, and then multiply by 0.025, and you should get the same answer. All right, number 6 says a jewelry company makes copper heart pendants. Each heart uses 0.75 inches cubed of copper. That's the volume. And there is 0.323 pounds of copper per cubic inch. And copper costs $3.68 per pound. What's the total cost for 24 copper hearts? So first, let's figure out how much. We've got 24 copper hearts. So we've got 0.75 for the volume for one copper heart. So for 24, that's 18 inches cubed. Now there is 0.323 pounds of copper for each cubic inch, so that would give us 5.814 pounds. And then the copper costs $3.68 per pound, so we're going to take 5.814 and multiply it by $3.68. A lot of multiplying in this one. 21.395, which is 2140, which is option 2. 20 says a cylindrical pool has a diameter of 16 feet and a height of 4 feet. The pool is filled half a foot below the top. So a half foot below the top. The top is 4 feet, so we're talking 3.5 feet. It's a weird way of wording that. How much water does the pool contain to the nearest gallon? So we're gonna have to figure out the volume and then figure out the gallons. Now, cylindrical pool, cylinder, capital BH. B is the area of the base. A cylinder looks like this. The area of the base is pi r squared. The diameter is 16, so that means the radius is half of that, which is 8. The height is 3.5 feet because it's filled to 1/2 of a foot below the top. So we've got a volume of like 703.7167544. This is feet cubed. 1 foot cubed is 7.48 gallons. So for every one of these, there's 7.14 gallons. This is times. So I'm going to multiply that by 7.14, and I get like 5,024 or 5,025. Oh, I typed the wrong thing into my calculator. 7.14. Where did I get that number? 7.48. I just copied this wrong. 7.485263, which is 5264 if you round. That's option 3. All right, next page. Sally and Mary both get ice cream from an ice cream truck. Sally's ice cream is served as a cylinder with a diameter 4 centimeters and a total height of 8 centimeters. Mary's ice cream is served as a cone with a diameter of 7 centimeters and a total height of 12.5 centimeters. Assume the ice cream fills Sally's cylinder and Mary's cone. Who was served more ice cream, Sally or Mary? Justify your answer. So capital B, H. Capital B is pi r squared, since we got a circle. The radius of this is going to be 2, so 2 squared, and then 8. Pi times 2 squared times 8 is like 100.5309649. Mary is a cone, so 1/3 capital BH. So 1/3 pi r squared h. The radius in this case is half of 7, so it'll be 3.5 squared, and then times 12.5. 1/3 times pi times 3.5 squared times 12.5 is 160.352125. So Mary was served more ice cream. Justify your answer just means show work, which you did. Determine and state how much more is served in the larger ice cream than the smaller ice cream to the nearest cubic centimeter. So we'll just have to subtract to figure out how much more. 160.352125 minus 100.5309649. Thankfully, I have these numbers in my calculator. That minus this. 59.8, but we're rounding to the nearest cubic centimeter, so that's going to round up to 60. All right, a small can of soup is a right circular cylinder with a base diameter of 7 centimeters and a height of 9 centimeters. A cylinder. A large container is also a cylinder with a base diameter of 9 and a height of 13. Determine and state the volume of the small can and the volume of the large can to the nearest cubic centimeter. So volume is capital BH. Again, these are cylinders, so pi r squared h. Small can, base diameter is 7, so that means the radius is 3.5. The height is 9. And we're rounding to the nearest cubic centimeter. So I'm getting 346.3, so I'm just going to call it 346. And then the large container is same thing, pi r squared h. The base diameter is 9, so that means the radius is 4.5, and the height is 13. So pi times 4.5 squared times 13. 827. What is the minimum number of small cans that must be opened to fill the large container? So, I mean, you can do this logically, or you have to fill 827, so you could start thinking, okay, if I filled it once, I'd have 481 left. If I filled it with another one, I'd have 346 left, or I'd have 135 left, so I'd need to open another can to do it, so that's three cans. Another way to do it is to take 827 and divide it by 346. Oops. Divide it, and you get 2.39, so you're going to need 3 cans. You can't have 2.39 of a can. So you got to open 3 small cans. All right, next page. It says a gardener wants to buy enough mulch to cover a rectangular garden that is 3 feet by 10 feet. One bag contains 2 cubic feet of mulch and costs $3.66. How much will the minimum number of bags cost to cover the garden with mulch 3 inches deep? 3 feet by 10 feet. So you got 3 feet by 10 feet. Okay, well, that's clearly not proportional, but you know what I mean. And then it's going to be 3 inches deep. So one bag contains 2 cubic feet of mulch. So you want everything in feet. You don't want to change everything to inches because this extra info has feet in it. So if we have 3 inches, let's go back to here, 3 out of 12, that's 0.25. So we're gonna call this 0.25 feet. So this is a rectangular prism, capital B times H. Capital B is the area of the base, which is length times width. So length is 3 feet, width is 10 feet, height is 0.25 feet. So 3 times 10 times 0.25 is 7.5 feet cubed. One bag contains 2 cubic feet. We have 7.5, so we need to figure out how many bags we would need and then how much it would cost. You could probably do this in your head. 2 cubic feet versus 7.5, 2, 4, 6, 8. You're gonna need 4 bags. Another way you could do this is divide by 2. And you get 3.75. But you can't buy 0.75 bags. So you're gonna have to buy 4 bags. Every bag costs $3.66. So times 366. So $14.64. All right. Josh is making a square-based fire pit. A square-based fire pit out of concrete for his backyard is modeled by the right prism below. He plans to make the outside walls of the fire pit 3.5 feet on each side with a height of 1.5 feet. The concrete walls of the fire pit are going to be 9 inches thick. Notice we've got feet and inches. A bag of concrete mix will fill 0.6 feet cubed. This is in feet, so we want everything to be in feet. 3.5 feet, 1.5 feet, 9 inches is 0.75 feet. Determine and state the number of bags needed to build the fire pit. All right, so we've got a square-based fire pit. So we're gonna do the volume of the whole rectangular prism, and then we're gonna do the volume of the inside part and take it away. So the whole, this is capital BH. Capital B means area of the base. Our base is length times width times height. Now, right now, the 9 inches doesn't matter. We're doing length times width. So length is 3.5 feet. Width, it says it's square base, so this is also going to be 3.5 feet. The height is 1.5 feet. I'm not gonna round, 18.375. That's the whole, like the whole entire thing. Now we're gonna do like the hole in the middle, and then we'll subtract. Now let's like look at this a little bit. If I wanted to do the length of this is 0.75, this is even, so it's 0.75. Whoops. So the whole thing is 3.5, but to get to this part, I'm going to take away 0.75 twice. So this is 2. Right, 0.75 plus 0.75 is 1.5, so 3.5 minus 1.5 is 2. So we've got a 2 by 2 box right here. And then the height is still 1.5. So volume is capital B times H, which is length times width times height. The length is 2, the width is 2, the height is 1.5. Is 6. So the volume is actually 18.375 minus 6. All right. So this is feet cubed. One bag of concrete mix will fill 0.6 feet cubed. That's it. So we want to know the number of bags needed to build the fire pit. So if one bag is only going to be 0.6, I got to divide this by 0.6 to figure out how many bags I need. So I need 20 0.625 bags, but I can't buy 0.625 bags, so we're going to call it 21 bags. All right, a sandbox in the shape of a rectangular prism has a length of 43 inches and a width of 30 inches. Jack uses bags of sand to fill the sandbox to a depth of 9 inches. Each bag of sand has a volume of 0.5 cubic foot. What is the minimum number of bags of sand that must be purchased to fill the sandbox? Whatever like extra information they give you, this is the units you want to be in. Cubic feet. So we've got a rectangular prism. And 43 inches. That's annoying. 3.583 repeating feet. A width is 30 inches. That's 2.5 feet. And a depth of 9 inches. That's 0.75 feet. All right, so now I can do my volume. Capital B for rectangular prism times H. That's length times width. Length is the 3.583 repeating number, 2.5, and then 0.75. So this times 0.75. So my volume is 6.718749 repeating feet cubed. And each bag of sand has a volume of 0.5 cubic feet. So one bag is 0.5 cubic feet, and I have 6.7. So if I divide this by 0.5, I can figure out how many bags I need, which is 13.4375, but I can't buy 0.4375 of a bag, so I'm gonna need 14 bags. That's option one. They're trying to trick you with 13. All right. A small town is installing a water storage tank in the shape of a cylinder. The tank must be able to hold at least 100,000 gallons of water. The tank must have a height of exactly 30 feet. 30 feet. What is the minimum diameter of the tank to the nearest foot? 1 cubic foot holds 7.48 gallons of water. So this is in feet. So when we calculate our volume needs to be in cubic feet. We know we need to get to 100,000 gallons. And 1 cubic foot holds 7.48 gallons. So our volume should be 13,368.98396 feet cubed. So over here, when I'm gonna do the volume calculation, capital B times H for cylinder, but this is pi r squared. We know the height has to be 30, and we know the volume has to be 13,368 point whatever. So how do I solve for r? First I'll divide by 30, but I'm gonna keep the decimal on this, so this divided by 30. So I get like 445 point whatever. I'm gonna keep the decimal on my calculator, I'm just not gonna write the whole thing. So to get r squared by itself, I'm gonna divide by pi. So I get like 141.849, blah, blah, blah. That's r squared. So to get r by itself, I'll have to take the square root. So r is like 11.9-ish, but this doesn't ask us for like the radius, it asks us for the diameter. So if the radius is about 12, then that means the diameter is gonna be double that, which is 24. All right, 33 says, a candle in the shape of a right pyramid is modeled below. Each side of the square base measures 12 centimeters. The slant height of the pyramid measures 16. Determine and state the volume of the candle to the nearest cubic centimeter. So, pyramid, 1/3 capital BH. Now, capital B is the area of the base, and this base is 12 by 12. Now the H though, that's not 16, that's a slant height. So the height of the actual thing is going down the center. So this is where you have to do the Pythagorean theorem. So if this length right here, that's the height, this is 16, this is gonna be right, this point right here is gonna be right in the middle. So it's gonna cut this 12 in half and make a 6. So I'm really looking at a right triangle that has a height we don't know, a 16 here, and a 6 here. So if we use Pythagorean theorem, h squared plus 6 squared equals 16 squared, we know that this is 36, 16 squared is 256. So to solve this, we're gonna subtract 36 on both sides, and then we'll square root it, 220. 220 is not a perfect square. We'll get like 14.83. And then it's really 14.83, 239.697. So I'm just going with the whole decimal. So when I do the volume of the whole thing, I'm going to do 12 times 12 times this whole thing to the nearest cubic centimeter. So 711.9 is 712 centimeters cubed. The wax used to make the candle weighs 0.032 ounces per cubic centimeter. Determine and state the weight of the candle. So 712 times 0.032 is to the nearest ounce. So 22.784, which is really going to be about 23 ounces. It says the surface area of a roof of a house is modeled by two congruent rectangles with dimensions 40 feet by 16 feet as shown below. Roofing shingles are sold in bundles. Each bundle covers 33 1/3 square feet. What is the minimum number of bundles that must be purchased to completely cover both rectangular sides of the roof? So this is just a rectangle. This isn't even volume. 16 by 40 feet, okay. 16 by 40 is 640, but there's two rectangles, so 1280. So we've got 1280 square feet, and each bundle covers 33 1/3, so 1280 divided by 33 1/3. $33 1/3, that's very annoying to do. So you can do 33 plus 1/3, 192/5, math, decimal, 38.4. You can't buy 0.4 of a bundle, so you'll have to buy 39. All right. In the diagram below, a sphere is inscribed in a cube. The cube has edge lengths of 18. So that means the diameter is 18, that's all it's saying. So this whole thing is 18, which means half would be 9. What's the volume of the sphere in terms of pi? That's 4/3 pi r cubed. 4/3 pi times 9 cubed in terms of pi means you don't have to type the pi in your calculator, you can just add it on afterwards. So 972 pi, option 3. The funnel shown below can be used to decorate cookies with melted chocolate. The funnel can be modeled by a cone whose radius is 6 and height is 13. The baker uses 2 cubic centimeters of chocolate to decorate each cookie. When the funnel is completely filled, what is the maximum number of cookies that can be decorated with the melted chocolate? Okay, this is a cone, so volume is 1/3, capital B times H. Capital B is pi r squared times H. We know that R is 6 and H is 13. So we're not doing anything fancy. Whoops. We're not doing anything fancy with this volume. Okay. So this is the volume that of chocolate that you can fit. And if they're only using 2 cubic centimeters, if I divide this by 2, that's going to give me how many cookies? So 245 cookies. That's a lot. All right, a building is composed of a rectangular pyramid on top of a rectangular prism, as shown in the diagram below. The rectangular prism has a length of 38 feet, a width of 15 feet, and a height of 22 feet. The rectangular pyramid sits directly on top of the rectangular prism, and its height is 12 feet. An air purification filter was installed that will clean the air in the building at a rate of 2,400 cubic feet per minute. Determine and state how long it will take to the nearest tenth of a minute for the filter to clean the air contained in the building. Cubic feet, this means volume. Everything is in feet, 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 feet. So we're good. So let's do the volume of the bottom. This is a rectangular prism, area of the base times the height. Base is length times width times height. 38, 15, and then the height is 22. One, 2, 5, 4, 0. Pyramid, 1/3, capital B times H. But that's also length times width times height. So it's the same numbers for the 38 and 15. The height is different though, that's 12. So 2280. Total volume 2280 plus 12540. 14,820 cubic feet. Now, it can clean the air at a rate of 2,400 cubic feet per minute. So let's divide that by 2,400. 6.175 minutes to the nearest tenth, so 6.2 minutes.